All right, so my name is Ksenia Figuero. I have been doing application security for coming up on like 10 years. I started, and actually, funny thing, I'm still with the same company. Like that does not happen in this world day and age. We've been acquired, but I'm still working with the same people. So I started as an application security consultant, as an intern, actually. And then after being in consulting for about 6-7 years, I switched more into research, and now I'm senior research engineer at Synopsys. I'm also doing my PhD at George Washington University, and this work is actually part of my academic research, so not directly linked to my work. But I've been doing research in JavaScript security for like 5 years, so it's still that area. And except for working, I also love doing ballroom dancing. I love diving. And I have a daughter. And I tweet security stuff on Twitter, so feel free to follow. All right. So why did I choose JavaScript? Except for doing JavaScript research for over 5 years, if you look at the Octoverse report that GitHub releases every year, from 2014, JavaScript has been the most popular language. And if we used to think that JavaScript is only in the browsers, well, of course not anymore. Now it's running on servers everywhere, basically. So in IoT and mobile devices, etc. So what is the state of JavaScript frameworks? And usually when we talk about frameworks, people usually start thinking about the client-side frameworks. I'll talk about the server-side frameworks as well. But I love this quote. And if you notice, this was from 2012. That's a long time ago. Has anything changed? Not really in that area. I mean, there are a lot of frameworks, right? When we talk about developing JavaScript applications, nobody writes vanilla JavaScript code anymore. It's all going to be frameworks. And currently, well, I think this data maybe is about 10 months old, but in client-side JavaScript, there are about 50 frameworks, as reported by a GS report. If you look at the server-side JavaScript, there are about 40 frameworks. There are full-stack frameworks that allow you to write code in JavaScript, both client-side and server-side, kind of seamlessly, such as Meteor and Aurelia. They're not as popular. I would say I haven't seen a lot of real production big applications using these frameworks, but that's definitely a kind of interesting area. There is a framework for developing desktop applications now with JavaScript, the Electron. And if you're using Slack or Visual Code Studio or WhatsApp, guess what it's written in? It's all written in Electron, the desktop versions. And then there's JavaScript in mobile applications, frameworks like PhoneGap and Cordova. So what is there in the frameworks for security? When developers choose a framework, how do they choose a framework? Well, they'll first look at the features. Does it do what I need to do, right? Is it a good framework for developing single-page applications or an API or a mobile front end? They look at, is it easy to prototype? Of course, the best ones, you just say, run app blah, and there you have the full backbones of the application, and you can start filling it in. It did a lot of work for you for prototyping. You look at performance. Is it quick? Does it do what, will it scale? The developers look at security. Well, let's put it this way. Do we choose the framework based on security? Not really. Like, very, very rarely we consider that, or at least we, look up, okay, how many issues are open on GitHub for this framework? Well, less than 100, probably okay, right? how many have them been resolved? Good enough, right? The other thing that developers often look at is community. Like that's a thing I haven't mentioned here, but is there enough documentation, right? Is it a popular framework? Is everybody else using it? If I have a problem, will I go out and find an answer? If I find a security vulnerability, will it be fixed, right? How well is it maintained? That's why these frameworks, supported by big companies like Google and Facebook, right? They do gain traction, like Angular and React. So in application security, when we talk about shifting security left, we talk about finding the vulnerabilities earlier in the development lifecycle, finding and fixing vulnerabilities, right, at the design level, et cetera. And I was thinking, well, if we're really thinking shifting left, can we prevent them? Because that would be to the leftmost, right, of this development lifecycle, is preventing the vulnerabilities versus finding and fixing them. So with that, I came with a couple of questions, right? Well, can frameworks help us with that? Can frameworks make our applications more secure? So I'll pose the questions, does the security of a framework help to make applications secure? And does building security controls into the framework help make applications secure? Because when we talk about secure framework, on like one part is the framework itself doesn't have any bugs. And the second part, does the framework provide security controls that I can implement in my application easily, quickly, out of the box? And the location of the security mitigation or security, I'm kind of using these terms interchangeably, vulnerability mitigation and security control. Because usually, if you fix or prevent a vulnerability, you're using some sort of security control. So does the location of that mitigation matter? And my former colleague, John Steven, came up with this structure, with this categorization where a mitigation can be placed in different places, in different parts of the application. So if we look at the app, so we have the framework, and then on top of it, I mean, we have like OS level code first, then the framework, and then the code that developers wrote. And then, of course, you're using different third-party libraries on the way. So mitigation can be placed, well, level 0, because this is academic research. Level 0 is no mitigation at all. This is our baseline. Application is vulnerable. Level 1 is a custom function, something developer wrote. Level 2 is external library, something developer pulled and started using as a sanitizer, as a access control part, right, as a CSRF protection, like any kind of security control. Level 3 is a framework plugin. And when I show you examples, you'll understand how they're very, very similar, but a little bit different. And then level 4 is a mitigation control built into the framework itself, out of the box. So if we look at examples, developer written function, obviously known. So I have some sample code here from an open source application that I was reviewing. And here's a custom developer function, which is trying to create cross-origin resource sharing policies, add cross-origin resource sharing headers to the application. Does this code look secure? The one in the box? Anybody with JavaScript experience? No? Why not?
It's easily reversed.
Easily reversed. But it's open source. It's going to be there, so kind of, you don't need to reverse it. It's there. Yep.
Allow origin is from any one star.
Yeah, allow origin is set to a wildcard. So depending on application functionality, if it's serving publicly available data, then it's fine. But if it is some sort of private data, user logged in, and now we're talking about the user's private information, account information, then any application can make a call to this application, and regardless of the origin of the request, the application will respond. So the point is developers make mistakes. Haha. And of course, you cannot have a slide deck without an XKCD comic, right? So that's why when developers write crypto, bad things happen. So that's common, right? Like we say that if it's a developer developed the security control, probably somebody developed that control before. Probably there is a third-party library or something that you don't need to write your own crypto, write your own authentication, like all of these things. So the second level, an external library. An example would be ASAPI. Anybody remember OWASP ASAPI here? Yeah, it died. So it was a great idea, right? It was a library that had a bunch of security controls. It had sanitization functions, authentication, authorization. But it sort of didn't take off. And parts of it were implemented very well. The problem with the SAPI was that it was originally written in Java. And for Java applications, I think there were versions for other languages later. But for Java, that library wouldn't work smoothly if you used a framework. So if you used struts, for example, and then you tried to pull in a SAPI, or you used Spring, and then you tried to pull in a SAPI, it was a pain to implement both of them. There was a similar project, Syserv Guard, I think, that had kind of similar problems. So not similar project, it was for Syserv, but it was a WASP library that implementing with a different framework was a pain. So then the third level, and that's how the plugin for a framework is different. It's, again, third-party library, but it is written for a specific framework, and then it kind of works out of the box smoothly. In the JavaScript ecosystem, there are tons of these examples. So there are, especially if I'm talking about the server-side Node.js JavaScript. So if we look at Express framework, if we look at Happy.js framework, if we look at Sails, there are a ton of third-party plugins written for these frameworks that are super easy to pull into your application and kind of make them work with the framework. And then an example of the fourth one is when the mitigation is built into the security, into the framework itself. One example is Spring Security, a framework that kind of has a lot of security features for you already built into it. You don't need to pull in a third-party library. So my hypothesis for this research was that, well, if the security controls are implemented in the framework, probably the applications are going to be more secure. So the closer we move down those 4 levels to the framework itself, the applications should be better. And of course, in academic world, like, well, you have to prove it with data. Kind of makes sense. So my first case study was for cross-site scripting. And everybody's familiar with cross-site scripting, how we can mitigate that. I'm not going to kind of go into details with this audience. But basically, what I needed to do is find open source applications using GitHub, of course. I wish I had access to private code, but that's not realistic. So I find applications that are likely to have cross-site scripting. Not every application is likely to have cross-site scripting, and like cross-site scripting that will be impactful. So to find these applications, I was thinking, when will cross-site scripting happen? It will happen when you allow users to put HTML markup into the application. So that should be functionality of the app that you would allow users to use HTML markup. And types of applications like that would be blogs, right? When you allow users to write their own blog posts, content management systems, marketing emails, for example. So any places where you want users allow using, fonts and graphics and what other like rich formatting text things. And when we need to implement that, basically we need to render raw HTML to make these magic things happen. How to do it safely? Well, you need to allow users to only use the safe subset of HTML, so they cannot insert malicious scripts. Kind of straightforward. And that can be done by sanitizing, whitelisting, blacklisting, or it can be done by using another language like markup that, again, basically only allows a safe subset of HTML. All right. So we collected data from GitHub with the following criteria, right? So we're looking for applications that are a blog or a content management system. At this point, I was interested in the full stack JavaScript, so that was kind of one of the criterias. And because that was 2016 when this research started, the front end there were 3 major frameworks, well, technically template engines that were written used for the front end was EJS, Jade, later renamed as Pug, and AngularJS. So those were the 3 frameworks, I'm going to call them frameworks here, that we looked at. And I also wanted to make sure that the applications are not super old, so I make sure their last commit was no later than 3 years ago at that time, had at least 1 star. I also looked at forks, so it's like somewhat popular project. And the language is JavaScript, HTML, CSS, like as long as it had JavaScript code. So we ended up with 170 applications, roughly a third in each category. And so let's look at the frameworks or template engines that they used and how they handle the raw HTML that we want to output as users. So all of them, by default, escape HTML. So for example, in Jade, Pug, if you're outputting with, using the equal sign or using the curly braces, it will, by default, do output encoding. We're safe. But if we want to output that raw HTML, allowing users to use, different fonts and pictures, etc., we would use the interpolation. So we'd say, not equals or not curly braces. Similar with AGS, it had a way to interpolate HTML. So those would be the things that we're looking for in the code, right, where we are outputting unsanitized data. And both AGS and Pug didn't have any way to have a safe subset when they're doing the interpolation. So whatever raw HTML you send them, if it's like not equals to something, they're going to output it as is. Which means if somebody sends a JavaScript, a script, it's going to be output as is, and that code will be vulnerable. If we look at AngularJS, again, that's 2016, so that was AngularJS at that time. It does also have contextually aware escaping by default. It also allows you to interpolate, so output HTML in a raw format. But if you're using it, again, the default interpolation using the ng-bind HTML directive, it will actually do sanitization by default. So it will only allow you the safe HTML subset and not allow scripts and events, like on error, on mouse over. And if you really want to output the raw HTML, then you would use the function trust as HTML. And around the data, and then add it to the ng-bind HTML. The newer versions of Angular still have that functionality. They renamed the function. It's now called bypass security trust HTML or trust URL, whatever the context is. So those were the things that we would be looking for in the applications. The pipeline. Basically, we had kind of different stages. So collect data from GitHub, get those templates from the applications. Then for the 3 different template engines, we used different parsers and then the rules to find those vulnerable locations. All of them are based on open source, since, again, this is academic work. So for Pug, I used the Puglexer and Pug parser, kind of extended those libraries. For EGS, I used the core EGS project, extended from that, and added the custom analyzer to it. And then for Angular, I just used ESLint and wrote custom rules for it. So scanned the code, then did manual analysis, manual review of the results, because none of these tools have data flow analysis. So even if they identify a place where raw HTML is displayed, not necessarily that raw HTML will have malicious data or tainted data, right? Because if it's not coming from a user, if it's coming from a hard-coded file that you control as a developer, it doesn't have vulnerability. So definitely want to make sure we're not reporting something that's not a vulnerability. And then we perform statistical analysis of the results. So what did we find? With the Jade, EGS, and Angular, and again, remember that the protection levels, because Jade and Pug didn't have any built-in sanitization, the only way to have the sanitization, did not talk about it, is to use mitigations of level 1 or level 2, is write your own custom sanitization function, or use a third-party code. Basically saying, okay, it's a blog post. This data is coming from a user of the blog who's posting something. I'm going to run it through my own custom sanitization function, and then I'm going to output that raw HTML that has been sanitized already. So that was the only way to make it safely in those 2 frameworks. So that's why I put them into mitigation levels 1 and 2. And then Angular had something out of the box. So this is level 4. And so we found that for G8 and EGS, 38% of the applications for G8 and 43% of the applications for EGS were vulnerable, versus only 12% for Angular. So that kind of proves our hypothesis, right? Angular has something built in. Applications seem to be more secure. All right. Again, in academia, which is different from the industry sometimes, so my advisor said, well, maybe the AngularJS developers are just smarter. Like, they just write better code. How do you know? How do you know it's because of the framework, right? So I had to think, I was like, okay, what can be other factors that could potentially influence that data? And of course, I didn't talk directly with developers, GitHub, open source projects. So I had to collect some proxies for the developer experience and knowledge. And what we did is we took the overall number of projects created by that developer. And again, by developer, I mean GitHub account, right? It's usually one person, but who knows, right? We have to make some assumptions here. So overall number of projects created by that developer, overall number of projects created in JavaScript specifically. So maybe they're experienced in general by the one JavaScript project and all of the other one are in C#. By project size, project popularity, the stars, the GitHub, the stars, and project reuse, the fork. So kind of showing how mature the application is. And then we ran the statistical analysis, the ANOVA tests, that showed that basically once you kind of plug the data and make the magic, statistical magic happen, you get the result, which is called this p-value, that if it is less than 0.05, that means that factor actually influences your results. And when we ran the analysis, we got that the only factor that actually influenced the result and had the correlation was the template engine. So success, right? So hypothesis proved, works, awesome. So the choice of the template engine matters. Okay, but that's only for cross-site scripting. So then I decided to look at other vulnerabilities, other frameworks, right, other types of code. So for the second case study, I chose cross-site request forgery as a vulnerability because I also wanted to look at the server-side JavaScript frameworks. And if we talk about cross-site request forgery, the server-side is kind of more involved in fixing the vulnerability. That's where you're going to be fixing the vulnerability. So who knows what a CSRF is? All right, so some people. But for those who are not super familiar, it's an attack, according to OWASP, right, where a user is tricked into executing an action when the user is logged into the website and is tricked by a malicious site and executing this action that the user didn't intend to. So in this case, the user is logged in to the website. In the same browser, the user goes to the evil.com website, and the evil.com website sends a request to the target website. And because it's coming from the same browser, the browser automatically attaches the user's session. And then the target website doesn't know if that request was kind of originated by the user legitimately, or it was originated by the evil.com site that's open in the user browser, right? So we don't know. The common protections, the most common one is the CSRF tokens. In this case, the target application first sends the token to the user, which is not a cookie. And then when the user sends the request back, this token is attached to the request. So then the target application can say, oh, yes, I did send you this token. It matches, that came from the user. Where if the request comes from the evil.com, it doesn't have a way to get that cookie from the browser. So the request either comes without that token or with whatever attacker came up with. So if the token is long enough and cryptographically secure, they cannot forge that token. And the request is not executed. And this can be done in post parameters. There is a way to do it through double submit cookie. I'm not going to go into the details. You can read on the OWASP website for more about it. Another way to protect from it is a two-factor authentication. You've seen it all in your banking applications, right? If it's sensitive enough data, if it's sensitive enough transaction, if you're sending money from one location to another, maybe they're going to ask you to, we send you authentication code to your mobile device, or you have like an Authy app or whatever. There are also ways to protect it on the client side. So one concept is the same-site cookies that is becoming more and more popular. Not all browsers support it yet. But basically, I think one thing I haven't mentioned is this attack is only possible when we're using cookies as a session management mechanism, right? If we're not using cookies, this attack cannot happen, because that's the whole point is that when the browser sends a request, it attaches the cookies automatically. It doesn't check anything. If that session information is sent not through the cookies, but through an HTTP header, for example, the HTTP headers are not attached automatically. The cookies are at fault here. So if we could have some sort of flag that says only attach these cookies if the request is originated from that same site. It's like if I am on bank.com and the request is coming from my bank.com page open in my browser to the bank.com server, attach the cookies. But if I have, funnycats.com open in the same browser, and now funnycats.com sends their same request to bank.com, the browser says like, oh, wait a second, the origin is different. I'm not going to attach this cookie because it's marked as the same site cookie. As I said, this is not yet supported by all the browsers. And then in academia, there were other solutions proposed, such as whitelisting expected origins. Like if I am the target website, I say, I do expect requests from these other websites, but not from evil.com. Or allow referral lists, so kind of similar idea, like if the refer equals this, then allow the request or not. But the refers can be easily spoofed. If you have proxies in between, they're going to be removed, et cetera, et cetera. That's why those were just academic proposals. So for this work, again, I needed a set of applications, open source, that are likely to have cross-site request forgery vulnerability. Not every application will, because what it needs for that is there must be a login, right? So the user, there should be some functionality that is only available to the user who is logged in, who has that session. And also, there should be some sensitive functionality, right? If I'm just logging in and viewing some information, and then I have my target website open, and then I'm going to the evil.com, and evil.com also sends a request to view the information, the GET request, right? Then the response is going to come to my browser. It's not going to go back to the evil.com. So CSRF only works if something changes on the target server, if it changes the state of the user account or data, right? So I need something that changes the state. And common attacks, common functionality that is attacked is, so you have a user profile, like changing an email address in your user profile. Why is that sensitive? Why is that super bad?
If you change the email, then you can get notifications sent to your personal account.
So you can get notifications to somebody else. Okay, what else?
Forget password.
Forget password, right? Somebody goes in, says, I forgot password. Send me a new password to a different email, and now they can have your account. Because oftentimes when people talk about CSRF, they talk about, transferring money to a different account. Like, come on, it's 2020. All banks have figured that out. That does not happen. There is you will have your second layer authentication, you will have CSRF tokens. Transfer money is not a good example anymore. But things like posting something from your account onto, Twitter, whatever, Facebook, something that you didn't want to post, especially if you are some, political figure, celebrity, whatever, that kind of compromise as well. All right, so what types of application will be vulnerable to that? So I was thinking, okay, blogs. If somebody posts something from your account that you don't want to, content management system, kind of similar. If it's an e-commerce, if somebody buys something using your account, that's kind of sensitive. And then just kind of generic REST APIs. So in this case, I looked at the server-side JavaScript applications. And again, so that was 2018. The most common frameworks were Express, Koa. Koa is right now even, well, I don't know if it's more popular than Express, but it's definitely picking up steam. Happy, Sales, and Meteor was kind of interesting. I'll talk about that in detail. So my goal was to have about 10 applications per framework. So go back. All right. So this is what we got. I got about 100 for Express, Koa, and Sales, and then Happy turned out not to be as popular on GitHub, so I was only able to find 48 total applications, and kind of, you can see in different categories, right? I looked for blogs and CMS and e-commerce, and that's actually when I added the REST API categories, because I just couldn't find any, that many CMSs developed in Happy, or that many e-commerce applications developed in Happy. And I was like, okay, well, there are some REST, because Happy is kind of targeted for REST API, so I was able to find 10, because again, I remember I didn't want any project, right? I wanted a project that had some stars, that has been contributed to recently, so it's kind of a little bit real. So a total of 364 applications. If we look at how these frameworks implement the CSRF protection, and again, I didn't choose the frameworks because they had different ways of implementing CSRF. I just wanted to look at what's most popular, right? What developers are using. So it turned out that Express, Koa, and Happy all had what's called the level 3 mitigation. So they had plugins for the frameworks to fix CSRF. So for example, Express and Koa, well, Koa is based on, kind of forked off of Express. That's why they're very similar. Basically, all you do is you add a plugin. You say, require CSRF or require Koa CSRF, and then you add it to the application. You can configure it, but then you kind of add it to application, and that's all. So it's super easy to use, 2 lines of code, maybe 3 lines of code if you're adding configuration. So it's, should be pretty easy for developers. Then if we look at Happy, is also very similar. You require a plugin, and you just kind of plug it into the main application, slightly different format, but it's, again, very straightforward. Sales is a configuration-driven framework. So and it also kind of claims to be pretty secure framework. So it has a lot of things built into it. And it actually had, one of the features was the CSRF protection built into Sales. So that's why it's level 4. And you would go into the configuration file, and you would just either say CSRF equals true, or you could go into more details and say, OK, I want to use CSRF on AJAX requests. I want to have a specific origin, kind of more detailed configuration. And then Meteor was a special case. As I mentioned before, Meteor is a full-stack framework. So servers developed in JavaScript, client developed in JavaScript. It's pretty fantastic because you're developing the application, both server side and client side, in the same IDE. Just like this folder is client, this folder is server. And it's interesting because the boundary of client and server washes away really quickly, and if it's the same person, and so which means the trust washes away really quickly. That's kind of a side note, but a lot of issues with Meteor applications that I've seen, developers will include business logic into the client that actually should belong on the server and shouldn't be in the client because you just kind of don't feel like those are 2 different things. The way the client and server interacts in Meteor is they are using their DDP, the Distributed Data Protocol, and that protocol runs on the web, through a WebSocket on the SSL level. So basically, when the client connects to the server, makes HTTP request at first, and then it establishes a WebSocket connection, and then it kind of drops the HTTP, goes down to the TLS level, and the whole communication happens in the TLS. What does that mean for CSRF? There are no cookies. So the first connection is important, and there are attacks that allow you to hijack that, but that's kind of a different group of attacks. But because there is no cookie, there is no way for another website opened in the same browser to send the request to the server and pretend that it's coming from the legitimate source. Because you cannot hijack, like suddenly just jump on that WebSocket connection and start sending your data through that WebSocket that has been already established. Of course, we assume that's all done over SSL. so secure WebSockets. So basically, if applications developed by Meteor, it cannot be vulnerable to CSRF out of the box. And then another caveat is JSON Web Tokens. So I think there are like 3 talks about JOTs in this conference. They're like super popular. And when Lakshmi was talking about them yesterday, she mentioned, for example, that they are bad. Like one of the drawbacks is that you cannot time out. You cannot invalidate a token, right? Well, they also come with some benefits. Because a JOT is sent as an HTTP header, again, there are no cookies. If you are using it for session management, there is no cookie, which means CSRF is not possible if you are using JOTs. So there are always trade-offs, as Alex Stamas was talking about, right? But basically, I also had to look at those applications from GitHub. Are they using JOTs? Because if they are, then they're not vulnerable. And as we talked about Meteor, because the mitigation is very different, right? It's sort of, for CSRF, it's sort of built into the framework, but it's basically impossible to turn off. It's impossible to do CSRF because communication happens at a different level. So I had to modify my categorization of these levels and add the level 5, the architecture level mitigation control, where the mitigation control is not just built into the framework, but it's kind of built into the foundation of the framework or the platform such that the vulnerability just cannot happen. So this is kind of the best way, right, on the framework design or platform level mitigation. And I'll give you later some examples that this is not just done once. Like it has happened in the history of software development before. So again, same hypothesis, does it work for CSRF? All right, again, similar pipeline. In this case, I had to write rules. I used ESLint for all of the different frameworks. And I had to write rules for just different plugins that I use and for sales configuration. But the rest was the same. So when we look at the results, they look very different. So for Koa, Express, and Happy all have mitigation at level 3, which is a plugin. They had 14, 19%, and then 35% for Happy, kind of high. And then Sales that had a framework level mitigation, level 4, it actually had only 14% of projects that were protected. So same as the level 3. And the interesting thing about Happy was that actually none of the applications, out of the 48 applications that I looked at, none of them had any CSRF protection at all. The reason why 35% or 17 of them were fixed, were not vulnerable, is because 17 of them used JWTs. So it's kind of like, oh, these developers got the protection for free. They didn't even know they got it. They probably didn't even know what CSRF is. Funny, there was one project. So if you look at Koa, there was one, so you see that 6 of them were protected with CSRF, and then 14 were protected with JWT, but the total number of protected applications is 19. Like, kind of math doesn't add up. So one application had actually both. It used JOTs for session management, but it also used a CSRF plugin to protect from CSRF, which tells me that developer didn't realize that if you're using JOTs, CSRF cannot be possible. So that's separate. But in any case, that means that my hypothesis does not prove for CSRF, right? Yeah, go this way. We ran the statistical analysis, just making sure if there are any other factors affecting this data. And sure enough, we saw that, no, everything is equal. There's not a different parameter that says, oh, the sales developers are just worse than the Express developers, or Happy developers are not just happier, but also better. They're just kind of equal. So yeah, the hypothesis did not prove, except for applications written in Meteor, because all right, well, you cannot even have that vulnerability there. So question is why, right? So if we compare cross-site scripting results with cross-site request forgery results, we can see that in cross-site scripting there is a strong correlation that if the protection is closer to the framework, applications are more secure. In CSRF, that's not the case. And I started looking at the level 4 protection, and turns out in AngularJS, that feature was enabled by default. Where in Sales, who also have the framework level mitigation, the CSRF mitigation was not enabled by default. By default, the CSRF flag in the configuration was set to false. So developers had to, and like that's all it takes. Just go and change false to true. You didn't need to do anything else. But most people didn't do it, which says defaults are kind of important. So what can we get from this presentation? What can we kind of from these results? Well, oops, go back. One thing is, well, ideally we choose the framework that has security features built in when we're starting developing an application. And then if it has security third-party plugins or configurations, if they're not enabled by default, can we make sure as an organization that these secure features are used by the developers, right? Can we write linting rules, secure coding guidelines, have code reviews that will ensure that that CSRF flag is actually set to true? I mean, how hard is that, right? You can't have a linter that's sitting in your DevOps pipeline and just checks that, especially for those configuration-driven frameworks. And the bigger message to the implementers of the frameworks, the builders of the frameworks, like, well, you kind of enable the secure defaults. That's, if it's possible. Oftentimes, it's not plausible because, like one example for cookies and the secure flag for the cookies, right? We'll talk about HTTP only and secure, and some frameworks have the HTTP only enabled by default because usually it doesn't break anything. But you cannot have secure flag for the cookie enabled by default because your prototype is probably not going to run on HTTPS, right? You're going to run on HTTP, so there are other dependencies to make that feature work. And then, so the security defaults are important. And then the last message is that if possible, if you are a framework maintainer, try to eliminate the vulnerability by changing the architecture of your framework somehow, if possible, right, ideally, so that this vulnerability just doesn't exist. And as I said, like it may sound very wishy-washy, it's like, oh, in an ideal world, we just build a framework so that there are no vulnerabilities. However, do we have buffer overflows in Java applications? No, because memory management in Java was, like in the JVM, was done so that buffer overflows are not possible. So that's exactly the example of that fifth level of mitigation. Another example is the ASLR, the memory randomization, right? That again, kind of invalidated the ability to just dump the memory and steal information from there. So these solutions do exist in the industry. They're not easy, but every now and then we're able to completely eliminate a class of vulnerabilities by a change in the framework, platform, OS level. So that would be great if we had more of those. And with that, we have a couple minutes for questions. I don't have a song. I know it's lunchtime. Feel free to go.
Hi. Would you consider under level 5 architecture how the application is deployed? Let's say if the application is behind a WAF, for instance.
What if the WAF at some point gets turned off, or you migrate the application? That's why it's a different. All of these protections are built into the application. The WAF is something that's outside of the application, so I feel like it's a completely different class. But yeah, WAF, IST, kind of, you name it, it's not in the application. So it's not, I'm not saying it's good or bad, but it's completely different. So.
Do you have any hypothesis as to why there are such different Do you have any hypotheses as to why there are such different results between cross-site scripting and cross-site request forgery, like the level of like security training people have or defaults?
I mean, cross-site scripting is definitely more popular, and that's why it has been built into Angular, right? Like if I asked show of hands who knows what XSS is, everybody's going to raise the hand, where CSRF is not. One thing I didn't mention, like why I chose CSRF, is if you look at OWASP top 10, cross-site scripting was always in the top 3. I think last time it says like top 4 or 5. It kind of lowered a little bit, but it was always like since 2003, it's always up there. CSRF in the last one, in the 2017, it's not in the OWASP top 10. Like, it's gone in some languages and some applications, and the reason why it's gone, for example, .NET and a lot of Java frameworks have it built by default. Like, it's something that you don't need to know the application logic to fix it. You can just say, hey, on every post request, require the token. Even on every GET request, require the token. So that's why I was hoping to get good results. That's why I chose it. But no, I didn't. So all vulnerabilities are different. I mean, I need to work more to finish this work and like add other vulnerabilities and other frameworks. Thank you.
So I just have a quick question.
There's a microphone.
I just have a quick question. You were not surprised by the conclusion that you put it on this, right? Even before you started the research.
No,
Those were expected, right?
I was expecting what I got from cross-site scripting. I was not expecting what I got
Right.
from CSRF.
But what I'm saying, the last
Oh, the last
presentation
slide.
slide,
Yeah.
those were, you were not surprised.
If
that-
secure defaults matter?
Right.
Yeah.
Yeah. So, okay. So I just wanted to know.
Yeah, I was not surprised by that, but that's the difference versus industry and academia, right? In industry, it was like, secure your applications, default matter. In academia, you come with it, and it's like, show me the data. Does it actually work?
Right.
I had to prove it because it's part of my PhD work.
Now, what happened after that? Oh, it was done?
I'm still in the process. I'm actually right now looking at Electron applications and trying to see what kind of tendencies and trends can I see, what kind of vulnerabilities, also like trying to look at the levels, but that's my next phase. All right. Thank you very much. Oh, yep.
Yeah, actually, so even though SQL injection is not a direct JavaScript-based vulnerability, it is used in conjunction a lot with frameworks. So have you thought about looking into like
SQL?
Yeah, like with parameterization of queries or developers trying to interact.
Yeah, that
with
can be definitely another kind of easy enough area to look at. So yeah, haven't looked at it yet, but thank you guys. Enjoy lunch.